Hi everybody, we're solving statics problems. Our topic, two-dimensional force systems. Our question, find the point where the line of action of the resultant of the force system shown in the figure, consisting of three forces and a couple, intersects the y-axis. Yes. We have a force system consisting of three forces and a couple. In other words, we have a force system consisting of five forces. Two of these forces form a couple. The moment of that couple is counterclockwise. A moment of 90 Newton meters applied at point O. We are asked to find the point where the line of action of the resultant of this system intersects the y-axis. Let's assume that the line of action of the resultant intersects the y-axis at a positive position. Let's assume that it intersects the y-axis at the location shown in the figure and try to locate that point. We will use Varignon's theorem to find that point. According to Varignon's theorem, the moment of the resultant about a point is equal to the sum of the moments of its components about that point. We will find the moment about point O. When finding the moment of the resultant about point O, we shift the resultant to where it intersects the y-axis. There, we resolve it into two rectangular components. The y component does not create a moment since it passes through O. Only the x component creates a moment. Therefore, we do not need to find our y. We need to find our x. Let's find our x. Our x is equal to the total Fx. In other words, we will sum the projections of the forces that make up the force system onto the x-axis to find our x. Let's add them. The x projections of the forces that make up the force couple are 0 because their sum is 0. Therefore, it has no effect. The 130 newtons force has a projection on x, and it is in the negative direction. When finding the projection of a 130 newtons force on x, the slope of the 130 newtons force is given. It is given with the right triangle 5, 12, 13. We will find the projection on x using this triangle. The side parallel to x is 5. Therefore, we find the x component by multiplying 130 by 5 divided by the hypotenuse. Since it is in the negative direction, we place the minus sign. Similarly, we can find the x component of the 150 newtons force. Its slope is also given with the right triangle 3, 4, 5. The side parallel to x is 3. We find the x component by multiplying 150 by 3 over 5. But since it is in the negative direction, we put a minus sign in front of it. The projection of the 80 newtons force below is also equal to itself, as it is, and in the positive direction. It is plus 80 newtons. We found our x is equal to minus 60 newtons. So, the force Rx is in the negative direction. That is, it's directed to the left. Its magnitude is 60 newtons. Let's write its moment about point O, 60 times y. Let's call the distance from the origin where the resultant's line of action intersects the y-axis y. We're looking for the y distance. 60 times y is the moment of Rx. It's also the moment of R. In other words, it's the moment of the resultant, because our y doesn't have a moment. Now, let's add the moments of the other forces. The moments of the forces that make up the couple are already given. It is 90 Newton meters, counterclockwise, that is, in the positive direction. We bring it back and write it down as is. Then, let's find the moment of the 130 newtons force on it. When finding the moment of the 130 newtons force, I use Varignon's theorem once again by resolving it into two rectangular components at its location. When I resolve it into two rectangular components where it is, I see that the y component passes through O, so it doesn't produce a moment. Only the x component has a moment. That, too, is found by multiplying the x component by 5 over 13. Its moment is in the positive direction. Its moment is plus 130 times 5 over 13. The moment arm is 2.4. The moment of 130 newtons, that's it. Let's move on to the 150 newtons force. When finding the moment of the 150 newtons force, I utilize Varignon's theorem once more by resolving it into two rectangular components where it is. The x component of the 150 newtons force is found by the side parallel to x, 3, the ratio of 3 to the hypotenuse, and the side parallel to y, 4, and the y component is found by multiplying by 4 over 5. The y component is found by. Let's add their moments. First, let's find the moment of the x component. The x component moment is positive because it creates a counterclockwise moment. 150 times 3 over 5 has a moment arm of 2.4. The y component is 150 times 4 over 5. The moment arm is 2.8. The direction of the moment it creates is clockwise, so it's negative. Minus 150 times 4 over 5. Multiply the moment arm by 2.8. Let's move on to the final force of 80 newtons. This 80 newtons force, since it passes through point O, it doesn't create a moment. Therefore, this force doesn't contribute anything. Using this equation, we find y. The only unknown in this equation is y. We draw y from here and find it. We find y equals 1.5 meters. Goodbye.